Get started. There it is. With our next session. And I must say that for those that stayed, you guys are lucky because we actually threw in 2 surprise guest speakers. And at the end, we're actually going to be going over recently published LCA results from our USDA grant. So really important stuff there. But I'll get started now. I first want to say thank you to Jean for being such a good sport. Like I said, we threw in 2 guest speakers, one of who is virtually joining us. So thank you for that, Jean. And second is I want to start with a quick reflection of what we've seen over the years. When we first started attending these conferences and we would bring in our talks around biodegradable mulch, I remember there'd be some members that would come in and would sort of not be so in tune with BDMs. And now we've seen that shift where we see a lot of manufacturers in the room that have started to explore those technologies. And the same way, we've also just seen an immense growth around recycling of mulch and updated the technologies. When we first came in, we also saw different mulch technologies that were being introduced at the time. And so we've gone through sort of this big shift. But outside of the room here, we have a series of stakeholders that have increasingly put their eyes onto these kinds of work. Organizations such as the environmental organizations from the Nature Conservancy to Five Gyres, but also other sort of collegiate federal government agencies. And that includes EPA that have reached out to us. NASA recently has also extended their interest in plastic culture. And the Water Board has also sort of started to pay more attention to all of this work. So there's a lot of eyes, and I know our speakers will touch on that. So I hope that with this talk, we're able to kind of encapsulate some of the efforts that have been going on in regions outside of the previous talks that have been included here. And so with that, my name is Jazmine Mejia-Muñoz, and I lead the plastic culture portfolio for the California Marine Sanctuary Foundation on the in the Monterey Bay National Marine Sanctuary. And our first speaker today is Chris Wagner. He's recently actually the Chief Operating Officer for Viaflex. Prior to that, Chris has served as the Vice President of Engineering for Viaflex, leading the plastic sheeting manufacturer. Or a leading plastic sheeting manufacturer. He holds a dual degree in metallurgical and materials engineering and interdisciplinary sciences from South Dakota School of Mindset Technology, and he has over 25 years of experience working across different industries, and he has spent his last 13 years in leadership roles at Ravens Viaflex, driving innovation and excellence in engineering. He'll be joined by Kevin Boehm, who that's the French pronunciation of his name. And he is the business development manager at Bioflex, and he has a bachelor's degree in composite materials engineering from Winoma State University with over 15 years of experience in a variety of engineering, commercial roles, automotive, composites, and plastic industry. And outside of their professional role, they are true enjoyers of pheasant hunting, as we learned last night. So with that, we'll pass it over to our speakers.
Thank you, Jazmine. So yeah, we had to do a audible. So with my recent move to CEO, I'm no longer leading this project, and so we wanted to make sure that the new leader of the project had part of the presentation as well. So that's why Kevin's on board here. So why is Viaflex here? It all started last year when James called that meeting and said that the end goal is that we want to do 100% recycling of our roll mulch from Driscoll fields, right? And Ben Andros and Andros Engineering were there and said, right now, we don't have a roll mulch that we can successfully do this without a large amount of labor and cost. And so the question was put to the film manufacturers that were in that meeting and said, okay, you guys need to design a film that can accomplish this goal. And so that is why we're here presenting today. Who is Viaflex? And so we're a film producer headquartered out of Sioux Falls, South Dakota. A lot of you might have known us by our previous name, which is Raven Engineered Films. We have 5 facilities throughout the United States. We were in 2022. Raven was purchased by Case New Holland, the tractor manufacturer. There was 3 operating divisions of Raven at that time. They bought it for one specific division, the precision ag. They sold off the other 2 divisions. And so we got bought by private equity and had to rebrand. And so we became Viaflex officially in 2022. So we have 3 locations in South Dakota, 1 in Colorado and 1 in Texas, supplying film to the energy market down there. So what is our markets? Like I said, energy is a big part of our market, servicing the Permian Basin with pit liners, evaporation pond liners, rig pad site, and so on and so forth. Geomembrane is a large part of our business. We're one of the few producers that will produce the film, convert it into a larger form factor, and then also do the install of the film. And we primarily do that in geomembrane, but a little bit in energy as well. And so we focus in on large ponds and large landfill covers, waste lagoons, that sort of thing is in our portfolio. Our largest market is construction, primarily in under slab gas barriers and vapor barriers, but also in building enclosures. You can see we're in ag, we'll get to that in a little bit, and then industrial. So flexi tank barrier tubing that goes inside of container that gets shipped overseas, lamination films and other custom composites. So ag film. We are actively in conventional and TIF roll mulches, broadcast films, silage film, as well as solarization and grain pile covers. We were one of the inventors or getting the TIF into the ag market. We developed that along with some others, but introduced that in the market and got that technology in place, as well as solarization film. That was one that we worked on and got that in place. So, but these are the ag films that we're currently playing in right now. At Viaflex, sustainability is a very big deal for us. So in 2012, we invested in our internal PIR reclamation capability. Currently, recycle 85% of our internal PIR or scrap. And then 10% is given to a local manufacturer and 5% is sold on the open market. And we are only operating this at about 50%. So there's plenty of capacity for us to take that further. In the past, before 2012, all of our scrap went into the landfill. And so we've made that investment to make sure that doesn't happen. We are a member of Operation Clean Sweep. We take that very seriously. So welcome any and all of you to come to the plant in Sioux Falls and see our operation. And it's very well done. Part of our sustainability effort is right now we are not utilizing that 15% of our PIR. We're either giving it to a local manufacturer or selling it on the open market. And so we have developed a patent to be able to reclaim the rest of that, and then waiting on getting approval to buy the equipment to make that happen. But that patent allows us to process a high percentage of that polyester that we have in our products. So. All right. With that, I will turn it over to Kevin.
Well, thank you, Chris, for that. So my name is Kevin Boehm. I'm a business development manager at Viaflex. In that role, my job is to really work as the conduit working between our commercial teams and our product development teams to deliver innovative products to the market. What I'm here to talk about today is the work we have been doing in the past year based on Driscoll's call to action to create and produce a 100% recyclable roll mulch product. To start off, we're just going to go over what current systems are like in the field. So there's been a lot of talk about it, mulch film down gauging. typical mulches are going in basically around 1 mil. Same with our products. Theron mentioned earlier, you can have a 6 mil film, you could pull it out. We would love that. But the reality is that is not economically feasible to the growers and the entire value stream. So what that leads to is the current films are like what you see on the side picture here. You get a lot of tears post-grow season. So it creates a labor-intensive removal process. Ben has touched on that. If you can't pull it out by hand, you can't pull it out the piece of equipment. So what you'll see is a lot of heavy soil loading with that thin film. You also get bulky and difficult to transport rolls that need to go to a MRF facility, something like that. We also then see significant amounts of macroplastics that are left behind in the field. This is something that's, it's a black eye for the industry. We know we need to fix it. And that's what we're committed to do is get to a system that 100% of the film that goes down also gets removed from the field, which allows it to go into the recycling streams. So what we're doing right now is we're going through quick iteration testing. So when we started off, we looked at, let's make these films, put them through a full grow season. The reality is we need to move quicker than that. If we wait for a film to get put down, go through a 3 to 6 month cycle and then pull it up, we're not getting results quick enough. So what we have developed working in conjunction with Ben and his team is we're forming beds. And instead of planting a crop, we are going through irrigating. We're trying to do our best to replicate the real world conditions. And then we can pull those samples up out of the field much quicker. That allows us to iterate. What we're doing is we started out, we bracketed and, started, okay, this is bulletproof, it's going to pull out. Well, what we can tell you for sure is we can produce a mulch film that is 100% retrieval possible. There's a video here. I don't know if you guys can start the video back there. Yeah. Okay, there we go. So this was actually taken just this week. We had a set of samples we pulled up out of the film and Andros's test plot. This is the ultra binder, so it's a smaller version of the mega binder. As you can see with the film, we'll go back, try to get to play again. We can shed a lot of the dirt. The whole film is coming up in one piece. We're working with multiple different methods of removing it, whether we pull it out of the field and pull it back with an ultra binder, or we put a mega binder onto a tractor and pull it up from the side, shedding that dirt. One of the big advantages is fully mechanical. It reduces the amount of topsoil that comes up with the film. You can see it shedding off in that video. We also get the added advantage of having highly dense rolls coming off. So Ben touched on it, Theron touched on it, having a product that can be shipped easily from the field to the next downstream process in the recycling waste stream is very advantageous. So what we're currently doing, so we pulled this material up, we actually deployed a new set of samples. Next month, we will go remove those. And what we're doing is we're refining the film structure and all the properties to get to a commercially viable mulch film that works for the growers and allows us to remove the film, but we don't want to get to the 6 mil film that Theron said. Nobody will be able to afford it. It won't work in the value stream. So where we're at, we're continuing these iterations. Our goal is to, by next year, we want to get into fields and plant into actual full crop cycles and do testing with growers. So we need the growers that are present here, growers that are working with the people in this room to give us opportunities to put this in their fields and continue the final iteration. We're looking obviously at strawberries, but we don't want to stop there. We want to look at all crops, different soil conditions, different regions. We also want to work on both conventional and TIF style films. And so this is where we're pledging. We want to answer that call to action. We are very committed to producing this 100% recyclable row mulch system. And it aligns exactly with our, sorry about that. It aligns with Bioflex's motto of protecting the earth while promoting industry. So thank you.
Great, thank you. And with that, we'll open it up to questions. Anybody want to follow up with any questions? I see Rory.
microphone in hand. So I know you're looking for growers and stuff, but have you tried it in for a full season? I know you're trying to expedite the process in testing. Yeah.
So currently,
This one's on.
there we go. So yeah, right now what we are focusing on is these expedited cycles. So what we're doing is, deploying the mulch onto a bed. We've done drip irrigation under, we're irrigating over the
Yeah.
field. We're running tractors through, packing down those tails to try to replicate the best case scenario. We're also going through poking holes, doing everything we can to replicate other than having that remaining plant canopy on it. And the main reason there is we want to iterate fast. We don't want to wait 6 months to get results so we can start again. So we're going to continue this iteration. We have the material we deployed will be pulling up next month. Based on that, we'll be ready to have another set of iterations that we can get in the field. That way we are ready come next spring to actually get material put into full growing cycles.
Okay. Yeah, I was just sort of curious. It looked like a pretty clean sheet of plastic there. I was like, maybe we can poke holes and all that kind of stuff. And but you do the whole punching and looking at variations, I think, from the shoulders and that kind of stuff. It's good. All right.
And I can add to that a little bit because as part of our sea grant project, which we've presented on last year, we're actually doing a low risk, low bed trial in Moss Landing. So we'll be doing a full season with their plastic and with some of the other plastic from manufacturers in the room. If anybody else is interested, of course, you guys could be part of that trial.
Nice presentation, guys. Kevin DeWitt with PDO Technologies. So is this a new product that you're just trying to sort of iterate to final sort of first article production that you can throw out in the field?
Yeah, correct. So we're long-standing presence in the mulch market.
Sure.
So we have existing mulch films that go through the same struggles where, removal, there's a lot of labor to pull those tails out. This is a next generation product that we are creating and iterating through. So.
Got it. Thank you so much.
Yes, I have a question. Have you thought about putting nanomaterials to actually increasing and enhancing the mechanical properties of the mulch film? Just because if it tears, there's an advantage in nanomaterials as it is.
No, we have not looked at nanomaterials, more macro materials and being able to successfully pull it out of that skirt area or the tuck. So. Yeah.
But we are open to any and all iterations. And so if we get to a point where we need to improve material properties, if it's needed, we're open to any and all solutions that will help us achieve this goal.
Yeah, I think we just need to understand the economics, right? We got to understand the grower at the end and make sure that it's still feasible for them to be able to utilize this product. So.
A couple of questions here. Great presentation. Thank you, by the way. What kind of trade-offs are you seeing in the manufacturing process with the development of these products, or are you seeing in the field? That's one. And the other is there any limitations in terms of the tools you're developing, the materials you're developing? Is there limitations in terms of what types of or colors of plastics you can manufacture with these? We have growers that there's a wide range of silver, white over black, clear, there's all kinds of stuff. So curious on those.
Right. Right now we have not painted ourselves in the corner and not being able to do all those different colors. No. Limitations for us is that it could be added processes on our side instead of coming right off a line. So.
Yeah, and just to add to that, so we do have we have a full portfolio, solarization, multiple colors, conventional TIF, everything we're doing at this point. We do not see a reason why we would not be able to offer that same full suite of options with this new and enhanced 100% removable roll mulch system.
It's Mark from CNG. There was a lot of discussion earlier about the gauge of films and the amount of soil left over on the films. With this new technology, is it a similar gauge to what you would normally see in the market for a conventional film, or is it upgauged? Or you initially spoke about gauge and not down gauging, but is this a upgauged version or equivalent to what's out there?
We are exploring, so our goal is to achieve a gauge that is similar to existing films on the market. We have played with upgauging along with numerous other methods of strengthening the film, enhancing properties through our different processes. So our end goal is to ensure that this is commercially viable, and we don't want the growers to be burdened with an additional cost that they do not recoup from the total economic feasibility of our film.
Great. Well, we'll move on to our next speaker. And I want to say, obviously, the California Marine Sanctuary Foundation has been involved in two major grants. The first one being Sea Grant, which was a $2.7 million grant, of which $1.5 million went directly to Flipping Iron for their investment in technology. And through that grant, I want to recognize that we've also been able to cover the future generation of sustainable professionals such as Rory, Michaela, and Alena, who will be joining her master's degree to work on this realm. And in addition to that, we have also explored end-of-life solutions or end-of-life alternatives such as biodegradable mulch, which Alena will talk about. I'll give a little bit of background as to why the Monterey Bay National Marine Sanctuary got involved into this area. So our commitment starts back in 2019 with initial assessment on plastic culture pollution that Alena will cover in depth. But this particular plastic was of concern for us because we see it as a high-risk marine debris potential. And the reason for this is this plastic is exposed in fields adjacent to waterways that drain directly out into the marine sanctuary. And in addition to that, compared to other plastics, for example, bottles or perhaps toys that might be left out on the beach, my plastic culture has 20 times higher concentration of agrochemicals, making it a high risk and increasing ecotoxicity. And so because of this, in addition to that, marine debris is one of the main focus areas for the Monterey Bay National Marine Sanctuary. We really prioritize working collaboratively with agricultural stakeholders. However, our portfolio expands around other areas. We've also worked with agricultural stakeholders in climate change adaptation, so looking at ways we can sequester carbon and looking at ways in which we can reduce runoff. So with that, I'll pass it on to Alena. And Alena joined CMSF in 2023. She serves as the Water Quality Program Associate for the Plastic Culture Division. Here, she collaborates with agricultural industry members to implement practices that improve agricultural water quality. She has helped conduct trials of soil-biodegradable mulch in place of traditional plastic mulch in strawberry fields, and she also explores different end-of-life solutions in a way to be able to reduce marine debris pollution from entering our oceans. Prior to Alena joining us, she served as the Life Lab farm manager, where she worked as an organic agricultural research assistant at the University of California, Santa Cruz. She holds a Bachelor's of Arts degree in Environmental Studies and Agroecology from UC Santa Cruz, where she has focused on sustainable organic agriculture and food systems and soil-borne diseases in strawberries. So with that, I'll pass it over to Alena.
Great. Thanks, Jazmine. And like Jazmine said, I'm Alena Anousinh. I'm a part of the Water Quality Program at the California Marine Sanctuary Foundation on behalf of Monterey Bay's National Marine Sanctuary. Before I get started today, I just want to give a huge shout out to Gene Jones and his team at SWIX for pulling off an amazing conference. And it's been amazing to see all the innovations and technology the industry has moved forward with. And I'm really glad that we can also be a part of the journey. So today I'm going to be discussing soil biodegradable mulches as an alternative to polyethylene mulches. Now this presentation is not advocating for certain strategies over the other, but for the instances where growers are unable to effectively remove PE mulch from their fields, or if recycling and landfilling is not a feasible option, biodegradable mulches can be an alternative in helping growers reduce the generation of plastic waste and reducing ag plastic pollution within soils. And so a little bit of background about who we are as national marine sanctuaries. We are federally protected bodies of water with historical, ecological, and economic importance. And so through our Agricultural Water Quality Alliance, we've collaborated with the industry on working together to implement solutions that can improve the health of water quality that's draining out into the watersheds, into our sanctuaries. And so we've worked on projects reducing nutrient and pesticide runoff. And today's focus is going to be on marine debris pollution prevention through sustainable plasticulture practices. And as you can see here, our work expands along 3 national marine sanctuaries across California's Central Coast, all which have watersheds in the top 3 producing strawberry districts in California: Oxnard, Santa Maria, and Monterey and Santa Cruz counties. So again, like Jazmine was saying, in 2019, the California Marine Sanctuary Foundation conducted an assessment of water banks in proximity to agriculturally dominated areas. And we sampled these stream banks after rainfall. And what we were finding was that the top plasticulture that was escaping off of fields and entering our waterways was polyethylene mulch. As we all know, PE mulch serves growers with many benefits. And in cases where soil-borne pathogens need to be fumigated with, it's actually legally required for growers to use PE films like totally impermeable films and fumigation films to help with the retaining those fumigations within those fields. And when looking at how growers are disposing their polyethylene mulch, the survey was conducted in 2016 by Washington State University, and they surveyed growers all throughout the nation. And as we can see here, the majority of growers landfill their plastics. And even with the majority of growers landfilling their plastics, we see that there's end-of-life management challenges that are prevalent, such as landfills that are becoming overburdened with polyethylene mulch waste. And we see with our changing climate, there's increasing storms and flooding events that can carry out this plastic into environments like the ocean, where endangered species such as sea otters can interact and consume this material. And on top of that, even with best management practices to fully remove these plastics from our soils, we see that there's legacy remnants of these plastics still remaining behind. Now, with these challenges, we see that there's pressures being faced all throughout the supply chain. In the grower's perspective, there's increasing landfill tipping fees. In Monterey County, we saw prices jump from $80 to $112 for agricultural plastics per ton. And in Santa Maria, this past year, it jumped from $80 to $156. And also, in the manufacturer's perspective, we see that there's growing legislation that's targeting plastic sustainability, such as California Senate Bill 54. So SB 54 mandates EPR programs for single-use food packaging, and this doesn't include agricultural plastics. However, as these policies and programs evolve, they could include agricultural plastics in the future, so it's something to keep in mind. And then on top of these pressures, there's auditors that are asking growers what their plasticulture management strategies are. We met with a grower last week. He was a strawberry grower, and they were conducting their sustainability certification audit. And one of the things that their auditors look for, and they ask for documentation, is what and where they're landfilling or recycling their plastics. And at the same field, there was a grower that was a vegetable grower co-rotating with the strawberry grower. And they were conducting their food safety audit. And one of the parameters that the food safety auditors will look out for is if there's excessive plastics remaining in the soils. And so if an auditor sees that there's a lot of plastic in your soil, they'll ask the growers to address that and send a crew in to pick up those extra plastic pieces before they can be certified for food safety. So with these challenges and growing pressures, we've seen that grower shippers have been exploring end-of-life management like recycling. And we also see that there's manufacturers that are exploring soil biodegradable plastic mulches. Now, BDMs, which are soil biodegradable plastic mulches, they're engineered to be tilled into the soil. So this eliminates any labor associated with removing mulch or any disposal fees. And so once it's tilled into the soil microbes will consume this material and convert it into another substance. So how they're manufactured is that they're made with feedstocks that are bio-based, made with fossil fuels or a blend of the two. And in order for them to be certified biodegradable, they have to pass these standardized tests where they reach 90% biodegradation in the lab within 2 years. And this is excluding photo and oxidegradable films. Those films are made with polyethylene mulches, and they did degrade from the sun. However, they degraded into microplastics, whereas soil biodegradable mulches, how they biodegrade is that how they're engineered is that they have weak links in their polymers. And so once they're tilled into the soil microbes will come in, attack those weak links, and they consume that material and they release carbon dioxide and water as a byproduct. And so currently we are in a nationwide trial supported by the USDA Specialty Crop Research Initiative. And today's focus will be at our trial in California, where 90% of the nation's strawberries are grown. And in our trials, we have different treatments. We have 4 different biodegradable mulches with different feedstocks in the colors green and black, compared with a polyethylene mulch made with PCR content, as well as the grower's standard polyethylene mulch. Now, biodegradable mulches are not a perfect technology, as you can see in this photo here. This is from our year 1 trial in 2023. And so we had some really strong windstorms and atmospheric rivers that essentially blew our trial apart. And when talking with the grower and the crew members, they had mentioned that our research runs were 50 foot long compared to the grower's standard, which is 200 foot long. And then they also left the ends of the beds untucked. So when the winds came in, it just blew our plastic away. So we took these lessons learned, and for our current trial, we applied them at the grower standard, which was 200 foot runs, and we kept the ends tucked into the soil. And so we have preliminary results of PSE, which is percent soil exposure. And so this is a visual assessment of the mulch deterioration during the growing season, because you want the mulch to still be intact and providing the benefits of a mulch throughout the season. So 0% PSE means that the mulch is fully intact and that there's no rips or tears or holes in it, whereas 100% PSE would mean that the mulch has deteriorated and that the soil is fully exposed. And so right now, our PSE is currently under 15%. So the mulch is still relatively intact. And then you'll see that the green biodegradable mulches have the highest PSE. And this is because they lack a carbon black pigment that acts as a UV stabilizer. And so we also have findings of yield. And right now there's no significant differences between the different treatments. And this is also still in progress. But this supports previous research findings that show that biodegradable mulches are a comparable alternative to polyethylene mulches and that they can be used commercially. And through our surveys with growers and our trials, we've identified some limitations to using biodegradable mulches. One of them is that you cannot use biodegradable mulches in organic systems under the National Organic Standard Board's rulings. And also, degradation can take up to 6 years in the field. Now, in the lab, and in order for them to be certified biodegradable, they have to pass those tests where they reach 90% degradation in 2 years. However, in the field, we've been seeing it take quite some time. But this is still significantly shorter than the lifespan of a polyethylene mulch. The next limitation is that BDMs cannot be used as a totally impermeable film, so they cannot be used to be fumigated underneath. And there's also limitations to using biodegradable mulches, and we've heard concerns from growers in California, especially because California has a really unique co-rotational system. For example, if a strawberry grower is growing on a plot one year, land is so expensive so that when they're finished with their season, a veggie grower will come in and grow their crops on that same plot. So if a grower, for example, used a biodegradable mulch, they till it into the soil, and it could take a few years for it to degrade. There's still fragments that are still in the soil. So if a veggie grower comes in and grows a low-bearing crop, such as a leafy green like lettuce, that is usually mechanically harvested and packaged on site, having those biodegradable mulch fragments could accidentally go into your produce bag, which is a huge food safety concern. Another limitation is that they're sensitive to bed management, as we saw in our year 1 trial, and that there also needs to be long-term effects of biodegradable mulches on soil health parameters. We've seen that there's not negative effects from 2 to 4 years. However, we do need more research past those 4 years to see if soil health is impacted. Now, with these limitations in mind, how do we envision a commercial expansion of biodegradable mulches, especially as we see that there is a need to reduce plastic waste generation and the persistent plastic pollution within agricultural soils? Now, BDMs can help growers when when recycling or landfilling fees are not available, or if they lack the methods for disposing of it or removing it. And we see scenarios where a grower may opt to use a biodegradable mulch in a conventional field that is flat fumigated. And if they are co-rotating, a co-rotation with a high-bearing crop such as a brassica crop. Now, we also see and have identified some beneficial vegetated practices that manufacturers can encourage their customers that are using biodegradable mulches to implement. For example, when the biodegradable mulches are still being used in the season, we see that end-of-bed grasses can help prevent strong windstorms from damaging the plastics and blowing it out from fields. And after the biodegradable mulch is tilled in, we see that cover crops and vegetated ditches could help with retaining these fragments in the soils and help prevent them from escaping off into neighboring fields or into other environments. And so before we came to this conference, we did a little bit of research into the organizations that were going to be here, and we looked into the strategic, sustainable plans of many of you guys in the room. And what we saw was a common focus was that you all are galvanizing your customers and empowering them and helping them towards their sustainable journey. And so we've identified a few opportunities where we can expand that. One of them is for the manufacturers is to develop agricultural plastic mulches that increase collection and reduce the fragmentation on fields. And a key challenge that we see in California is efficiently removing plastics from soils that are heavy and clay-like. So it's great to see that there's innovations headed towards that way, and we need more of that. Also, beyond application, we see that there's room for expanding domestic recycling efforts. And we saw with Yufeng's research that there's focus and there's movement in recycling mulch into asphalt. And also we see that there's growing research beyond plastic into other alternatives, such as lignocellulose mulches made from plant material and even paper mulches. Now, the California Marine Sanctuary Foundation has been a leader in collaborating with the agricultural industry on sustainable plasticulture management. And we actually just celebrated our 30-year anniversary. And so with these opportunities in mind, we'd like to ask you, how can we collaborate and explore these opportunities together? And with that, I'd like to give an acknowledgement to the USDA Specialty Crop Research Initiative for funding our work in exploring soil biodegradable mulches and also looking into different end-of-life management practices such as pyrolysis and Kevin's work at PDO and Yufeng's work in mulch to asphalt. And before I get to questions, I do want to give a shout out to the Washington State University team and all our partners, and also the Mulch Matters podcast, which is all about plasticulture. And we actually have a few guest stars in the room, Kevin and Ben Andros, and even James from the Driscoll team and Jazmine have all been a part of this podcast. It's a great listen and really easy to digest. So I highly recommend that you listen to it on your way to the airport if you're going off to the beach later today. And so with that, I'll take any questions unless we transition to, okay. And we're gonna go to our next guest speaker.
Thank you, Alena. And yes, we'll save questions for you and Dada at the end. And Dada, I don't know if you can hear us.
Yes, I can. Can you hear me well?
And we'll be seeing you on the screen, Dada, so you'll be able to share your slides.
Okay. Can you hear me?
Yes. And
All
Dada's a doctoral candidate at Washington State University in the Bioprocessing and Bioproducts Engineering Laboratory and Department of Biological Systems and in the engineering department. And Dada has been working in our USDA funded project along with Ying Yang. And together they'll be presenting some recent findings that they have from their life cycle assessments. So these are going to be important topics for you all to consider as you're moving forward with your sustainability pathways.
Thank you for that, Jazmine. Yeah, so thank you to everyone, and thanks to Jane Jones for shipping me and Jane in. So before we start, a little introduction to this presentation. So we'll be covering two aspects of plastic, agricultural plastic waste management. The first aspect relates to the PE mulch, as we can see from the previous Anela presentation, that plastic mulch is a problem and it needs to be managed. So in that sense, we will be presenting on how to manage agricultural PE plastic mulch through recycling, and we'll be considering pyrolysis, asphalt, and wood composite board production. And the second aspect of this presentation will be on the biodegradable mulch, which was also part of Alena's presentation. And in that aspect, we'll be dealing with how to manage the mulch residue as it relates to environmental sustainability. So this presentation is all about life cycle assessment and how sustainable all these processes and end-of-life options are. Without further ado, let me dig in. So I'll be presenting on comparative life cycle assessment of agricultural plastic mulch film recycling. So this one is handled by Jain, which is on the call also. So a little bit about the methodology, because we didn't want to bore you with all the methodology, so we had to put it into short presentation. So in here, we did life cycle assessment of PE mulch recycling processes. As I said, which included, hold on, let me get my pointer, which included the WPC, which is wood processing composite, and also the pyrolysis and asphalt. So the base scenario were open burning and landfilling. So this study is gate to gate, which means it doesn't consider the end use of the products produced. So, and what does that mean? It means we collected the mulch film and it goes through the technology and produces a product. But what happens to the product after, we did not consider. So as I said, the base scenario are open burning and landfilling, while pyrolysis, wood, plastic composite, and asphalt modification were the major technology considered for PE mulch recycling. And in this WPC production, we consider the shredding of the plastic waste and the mixing with the wood flour and also the production of the WPC board. For the pyrolysis, we consider the shredding of that plastic waste, and when it goes to the pyrolysis reactor, where it is combusted under no oxygen and is heated to produce gases and solid waste. I mean, solid component. And that's those solid components, we do not consider what happens to it. But in the gas, when you condense it, or we call it when you condense it, then you should have syngas or diesel. So that let's just call it pyrolysis oil. So that is the process for pyrolysis. For asphalt, we consider the shredding of the mulch film, and we pelletize it, and also we had that mulch film to bitumen, and produce asphalt production. So in WPC board, this is where the mulch film is incorporated. In pyrolysis, the pyrolysis involve the mulch film from the beginning. Then for the asphalt, this is where the mulch film is incorporated. For the asphalt, we consider 4% of mulch film to the other component of the binder to be bitumen. So this is necessary to understand the system boundary of what we consider, so that when we are presenting the result, we understand you must have had a big overview of what we did. So the functional unit was the 1 ton of PE mulch waste, and that 1 ton contains 30% soil contamination. So we use the impact assessment method Tracer 2.1, which is specific to United States as the impact assessment method. So to the result, this is the overview of the result, and we found out that pyrolysis and asphalt modification reduced environmental impact. And this is it here. So this graph shows you a normalization score. So there is a baseline score, and all the environmental impact were divided by that baseline reference score to generate this normalized impact score. So the higher the score, the higher the environmental impact. So pyrolysis happens to be the lowest environmental, it happens to have the lowest environmental impact, which means it's most sustainable within the scope of the study, and followed by asphalt. So pyrolysis achieved 0.68, and the environmental burden of pyrolysis was due to the environmental benefit was due to energy and byproduct recovery, because you generate syngas, generate diesel, and that offset the contribution from producing those energy. So, and also for asphalt, when we consider the 4%, which is like a good percentage when we consider literature and industry-based production processes. So 4% of the PE, the 4% of PE also is also part of it's also a functional unit. So it's not that the 4% is the 4% is just 4% of the functional unit. No, it's the functional unit. So when we consider the incorporation of PE mulch into the asphalt as binder, and we consider without PE mulch as binder here, it also shows that it exhibits more sustainable process. So using it is beneficial due to it replaces the asphalt binder. The bitumen is generated from fossil resources. So, and it's clear that open burning was the worst. So, and also followed by landfilling. WPC board does not produce much environmental benefit when compared to pyrolysis and asphalt. So with that, let me go to the breakdown of it. So this graph here, this figure here shows the impact assessment result, which means the score we generated when we analyze the environmental impact. And from here, it is clear with what I presented in the previous slide that pyrolysis was the best. And when we compared with the baseline for landfill, we found out that asphalt can reduce global warming by 55%, and also fossil fuel by 31%. So this is due to the incorporation of that PE mulch waste in asphalt. So asphalt production with PE mulch appears to be more sustainable. And also for the pyrolysis, it's excellent because it reduces the global warming potential, which is climate change, by 70%. And for all the advanced recycling scenarios, ecotoxicity was reduced. So with Jazmine's concern about and Alena concern about ecotoxicity, you can actually reduce ecotoxicity when you practice the recycling of this agricultural plastic mulch films. And we saw that ecotoxicity was reduced by 80%. And this ecotoxicity is going to be explained in the next section of the study. So open burning is a no-no because it increases the global warming and ecotoxicity. So now to the section of the biodegradable mulch film. This biodegradable, as I explained, is focused on the end of life of biodegradable mulch film. We now compared it to polyethylene mulch film landfilling scenario. And in here, we consider from cradle to grave, from the extraction, feedstock production, to the material processing, film production. Then we use it on the farm. And when we finish using it, it's either we leave it on the farm for soil biodegradation, or we collect a portion of it. 70% was what was assumed there. We collect it and we take it, transport it to composting facility, anaerobic digestion facility, or for PE mulch, we collect it and we dispose it in landfill. So for this soil biodegradation, we assume 100% mineralization, which means that the bacteria within that considered period, the bacteria hacked on it, breaks it down, and peat was generated. For the composting, compost was generated. For the anaerobic digestion, there are two products, the biogas and the electricity. So with this, these are avoided products. And it means that, instead of you producing it again, you have the benefit of the product. So it was avoided in the process. The system body, as I said, is from cradle to grave. And the HEOL, the end of life processes we considered was soil biodegradation, anaerobic digestion, and composting. That is for biodegradable mulch, and we consider landfilling for polyethylene mulch. The functional unit was a kilogram. The kilogram of mulch used for 1 hectare of strawberry field covered. And since California is the leader in strawberry production, our data was focused on California. And we used the same impact assessment method as the previous study. So to the result, we found out that biodegradable mulch is more sustainable than polyethylene mulch within the scope of this study. And it is clear from this graph here. This graph shows the overall impact result. And it shows that this is biodegradable mulch with composition of PBAT and TPS. This is biodegradable mulch with composition of 70% PBAT TPS. This 30%, this 70% PBAT TPS, 30% PBAT TPS, and this one is 70% PBAT PLA, and this is polyethylene mulch. So it is clear that when you use more percentage of TPS, which is thermoplastic mulch component, thermoplastic starch component in the mulch film, you have more environmentally friendly result. And that is because the thermoplastic mulch degrades easily and than the PBAT component, than the PLA component. So the polyethylene mulch manufacturing was more sustainable in the result. So now when you practice the production of polyethylene mulch and the production of biodegradable mulch, polyethylene mulch appears to be more sustainable. So, and this is due to the burden of feedstock, biomass feedstock production of the biodegradable mulch, because it involves a lot of farming, a lot of cultivation, a lot of processing. So that makes the production to be less sustainable. But when you look at it, this benefit of polyethylene mulch is actually lost in the end of life scenario. So now, from this result, from this graph, we found out that when you use biodegradable mulch, you can actually reduce the overall impact by 3 to 20, around 21%. And when you increase the composition of the thermoplastic starch from 30 to 70%, you have overall improvement, impact improvement of like between 19% to 21%. And it's clear, though the biodegradable mulch production is less sustainable than the polyethylene mulch production, but it uses less fuzzy resources. It uses less fuzzy fuel, like that of the polyethylene, which comes from crude oil. Now, to the overall end of life result. As I said, the benefit is lost. And as you can see from this result, this one is PE mulch landfilling. The major problem here is the ecotoxicity. And if you can address the ecotoxicity, then you will make the polyethylene mulch more sustainable. And in that sense, that was the reason for we going through the advanced recycling, which I presented in the previous section. So the mulch use stage shows similar result. So, but if you practice composting, composting requires a lot of heavy equipment. So it increases the environmental impact. It is not sustainable. But when you consider the anaerobic digestion and soil biodegradation, we found out that AD compared to composting, AD reduces impact very much, like double that of composting. So soil biodegradation and anaerobic digestion appears to be more sustainable option for managing the biodegradable mulch film waste. So, and as I said, from this result, this is the anaerobic digestion. This is anaerobic digestion for TPS, anaerobic digestion for PLA, mulch film. This is soil biodegradation, this composting, this composting. So when you increase the portion of the TPS, there is more degradation and there is more bacterial degradation, which generates more biogas, and that biogas increases the benefit of anaerobic digestion. Now, to the overall overview and recommendation, this study is actually valid within the scope of the study, and caution should be taken not to overgeneralize, because we did not consider what happens to the product generated through pyrolysis, maybe the combustion of diesel. We did not consider that. The use of WPC, maybe after 20 years, what happened? Do you incinerate it? We did not consider that. That of asphalt, okay, maybe after 20 years, you remove it. Do you recycle it to hot mix or cold mix? We did not consider that. And the reason being that it's not functionally equivalent. So we did not consider the what happens to the product after use. So that should be taken into consideration. So the recommendation is to avoid open burning. That is a no-no. We found out that some still perform open burning, and landfilling also is not sustainable. But if the product is the focus, you want to see the impact of the product, maybe syngas, diesel, then it's the pathway that is more sustainable is pyrolysis, followed by asphalt modification. So, and that will help to actually contain some plastic mulch film waste in the environment and avoid the transfer of this mulch film to adjacent water bodies and increasing marine ecotoxicity. For soil biodegradation, so for soil biodegradable mulch film, it is advisable to avoid composting because it increases impact. So soil biodegradation still remains the most beneficial pathway, both economically and environmentally. And what I mean by the economics is because if you practice anaerobic digestion, you still have to consider the cost of removal. And also, there is a challenge for anaerobic digestion, which is the low degradation of the PBAT component. The PLA does degrade better than PBAT, but PBAT component, the degradation is very low. So that generates residue. And what happens to the residue is that you collect it, you dispose it in the landfill. That one also, though that one at least is going to degrade within a year or two, but it's still a burden because we're going to collect, transport. That's economics. So overall, we study the environmental sustainability of both PE mulch and BDM, and these are the recommendations. And we acknowledge the support of the USDA, which funded the study, and for Washington State University Small Fruit Horticultural Research and Extension Program, and also the Bioprocessing and Bioproducts Engineering Laboratory, which gave us the platform for this study. And that's it from our end. Thank you very much.
Great. Thank you, Dada. I really hope that you followed all of these LCA results because these are impactful. And one of the things that if I may, I'm going to comment on is that if you're looking for your own operation, you really have to think carefully about a scenario analysis. Because, for example, in California, this analysis considered that all distance were equal. In California, pyrolysis is not the same distance, so that you would then have to consider transportation, which can really change the results. And as Dada mentioned, once you start taking into consideration, instead of gate to gate, a gate to grave, so the end of life process of that, then the results might change. But with that, I know we've come to the end of it. Do we have time for 1 or 2 questions, Jean? Okay, we'll have time for 1 to 2 questions.
Thanks. I have a question about the LCA that was just presented. If you've been in the last few sessions, what is commercially viable, what's actually happening at a broad landscape scale in terms of end of life for mulch is PE mulch being retrieved, collected, pre-processed, and recycled. It's being converted into other single-use plastic materials. Maybe I'm not seeing it, but is that process that's now it could be 15,000 acres total that's gone through that process, is that reflected in the LCA? And if not, can it be in the future? I mean, that's really what's happening in a commercial basis now. So I'm not sure if the presenter can hear me ask this question.
Yes, I can hear you well. So you are asking if our scenario considers the recycling of PE mulch for single-use plastic? No, we did not. Yes. We consider the use of this plastic waste because in the SCRI UL team, we have a section that considers pyrolysis, the wood plastic board, composite, and also the asphalt. So we looked at how sustainable these processes are and also to give the environmental hotspot and how to improve the process. That was considered in this study. So going forward, we might have to consider other processes.
Great. I would please do, because it is the grower. It is quickly becoming the grower standard. It's not just PE mulch. It's a recycled PE mulch. That's the scenario to review. So yeah, it's happened really fast. And I know that this LCA has been going on for quite some time, but for future versions, I hope that would be included.
For that, are you referring to the end of life, like where the PE mulch is ending up at, whether it's bags or other materials?
Well, it's not cradle to grave right now. So if it's, I think the boundaries of this LCA, it doesn't really matter what single use product it's being converted into. I think it matters that whether it's construction sheeting or plastic bags. I think that's the point of comparison. If it's cradle to grave, eventually, great. It'd be interesting to compare that to pyrolysis and to asphalt disposal as well. So, but either way, I mean, it's important that in my opinion, it's important that this work reflects the commercial realities as the base case.
Yeah, I agree.
So I have a question. On a recycling standpoint, in the case of a mismanaged material from one site to the other being biodegradable to PE mulch itself, how does that affect the mixture of both when you have a final product on a mechanical process that you have a final pellet? Will it affect it, or do you have data on that?
So, okay, are you referring to the environmental perspective or the processing itself? So
basically,
okay.
I'm just trying to see if there's let's say if me being a recycling facility, if I receive by any chance a load that's pretty much biodegradable and it gets mixed into the stream of PE, do you have any data supporting what happens to that? If it's gonna degrade the plastic, because once it's mixed in, it's very hard to take out.
Yeah, and that is the part of the waste collection process. In this study, we consider PE mulch So for the recycling. So we assume it's only PE mulch and not a mixture of them, because that will reduce the percentage of PE mulch that is pyrolyzed or that's used for HVAC, and also affect the structural or the mechanical aspect of it. So this LCA does not consider the mechanical aspect. It assumed 1 ton of plastic waste was used in the process. So if that the structural viability of having some, let me call it pollutant or some waste in the flow, that will have to be assessed in the environmental, I mean, in what is it called? Outside this SCA. But this SCA assume purely is a PE waste and not a mixture.
I won't
Yes.
speak to the LCA because I'm not part of the LCA team. But what I will say is that you're absolutely right and that it should not be mixed. And that's one of the information that has to be delivered specifically to the grower as they're applying.
Yeah.
And in addition to that, if the grower was to be removing the plastic and pulling it out, this practice would now become cost prohibitive. The price would increase significantly because the price or the labor savings comes at the end. So if you're trying to remove this plastic, which one is meant to biodegrade during the season, it would be really difficult to remove. And two, now your whole practice for that, the price would increase because you would be paying more for buying it in the front and then at the end paying for extra labor.
Yeah, that question came up, I think maybe 5 or 6 years ago when we
Yeah.
first started talking about
It's
it.
come up
What
every single
what
time. Yeah.
problems are we causing
Question.
recyclers?
Thank you. My question is for Alena. Have you seen any effect on the roots of the strawberries during the trial?
Sorry, did you say the root surface?
The roots in general, in the growing of the roots.
Yeah, no, we haven't looked into the root structure of the plant itself. The parameters that we looked at are the percent soil exposure, so the mulch deterioration, and then we collect the yield of the strawberry plants and temperature data, but we haven't looked into the root structure of the plant itself. Okay, thank you.
Any other questions?
Maybe Alena for you. I'm just curious, it seems like this is a new food source for microbes that are in the soil. Has there been any study in what the soil condition is, and are these favorable or are these?
Yeah, the Washington State University team has looked at how the soil microbes react to the soil biodegradable mulches, and it does serve as an extra food source for them. So they do see an increase of the microbes. And also, it hasn't impacted, like, because I know there's good microbes and bad, but there hasn't been like a population change between like bad microbes growing and accumulating within the soils.
Are
as
you
well.
speaking? We can't hear you.
Yes, they were talking. You got sound on? You got sound on for the virtual? You just turn it off because I don't think Data can hear us.
Great. Well, with that, we'll wrap it up. Thank you all very much.
Thank you.
All right, thank you.
Hi,
Madeline.
Jazmine. Is there any question for us here?
And
can't hear
in
you.
closing, let me just say, I will
Go.
wrap up all the proceedings. So you'll get all the presentations that you've seen in PDF format. It's going to be next week because I'm going to the bar right after this and drink a beer. And then virtual, all the presentations, we'll put that up on a YouTube channel. I'll be sending out an email to everybody, try to get some, feedback from you all. We'll do a kind of a survey post-event, whether we do the event next year or whether we wait a year. If we come back next year, I don't want to repeat what we just did. I want to see some progress within the industry. So that's to be decided. So have a safe trip home and thank you, everybody.
We're doing so I like to look at gains and tests and